Question 1 shows the distance time graph of a bus with time, and you are supposed to find the average speed of the bus. So given a distance time graph, here the total distance traveled is y and the total time taken is t2. So with average speed is given by total distance over total time, and that will be y over t squared. Now this is a distance time graph. Now what happens if you have a speed time graph? Then it is different. The way you calculate the average speed will be different. So if this is a speed time graph, then the average speed will be given by area. So it will be area P plus area Q over T2. Question 2 shows a speed time graph of a cyclist, and you are supposed to find out how far the cyclist has traveled when the acceleration is negative. So the acceleration is negative means that the cyclist is slowing down or the speed is decreasing, and that happens from 30 seconds to 60 seconds, and distance is the area under the speed time graph, and that will be half times 8 times 30, and that will give you 120 meters. In question 3, you have a ball that is dropped from the top of a cliff. So at the start, there is no air resistance, so the initial acceleration of the ball will be g. Then when it falls, as it falls, the speed increases, the air resistance will increase. This causes the resultant force to decrease, and therefore the acceleration will decrease. And this causes the speed to increase, but at a decreasing rate. So what that means is that the distance will increase at an increasing rate until the speed is constant. So looking at these 4 graphs, so in graph 1, the speed initial speed is very fast, and it becomes constant or zero speed. But in graph number 2, the speed increases until it becomes constant speed. Graph number 3, the speed increases, but increases slower at a slower rate until it becomes constant speed. In graph number 4, the speed again increases, but it increases at a faster rate, and the speed just continues to increase. So in this question, the answer will be graphs 2 and 3 will represent the motion of the ball. Question 4 is on vector addition. So you have a 3 Newton force and a 4 Newton force, and what is the value of the resultant force? So draw a parallelogram and draw the resultant force, and then you can use Pythagoras theorem to find the magnitude of the resultant force as 5 newtons over here. Question 5 has an object with a mass of 0.45 kg, and you are asked what is the minimum lifting force that the student needs to apply to lift the object. And so the minimum lifting force is really just the weight of the object, and W given by mg, and that will give 4.5 newtons. The value of the 0.8 meters per is from the ground is really a distractor and is not used in this question. In question 6, you have a car of mass 1200 kg. The engine produces a forward force of 3600 newtons, and the car is moving at a constant speed of 30 meters per second. So what this tells you is that the forces are balanced, which means there must be a frictional force of 3600 newtons. So when the engine now produces a forward force of 4800 newtons, there is still a 3600 newton force of friction, and this causes the resultant force equals to driving force minus friction equals to ma, and you have to use 4,800 minus the frictional force of 3600 newtons, and that will give you the acceleration of 1.0 meters per second square. Question 7 asks for the definition of a gravitational field. So here, gravitational field is really defined as a region in which a mass experiences a force due to gravitational acceleration, and that is the definition of a gravitational field. So any object with mass will have a gravitational field. Alright. Question 8 requires you to find the moment of a force, and you will recall that moment is defined as force times perpendicular distance from the line of action of the force to the pivot. So here we have a force F, and this force F line of action refers to this line. And since this is the pivot, there will be a perpendicular distance. So the line of action of the force and the perpendicular distance, that will give you the moment. So F times D will give you the moment of force F. Question 9 is about a tractor and where is the safest position for its center of gravity. So the safest place is that you want a low CG and be within a base area. So you want the lowest CG within the base area of the wheel. So in this question, that will be D. In question 10, you have a mass that is hung from a spring. It is pulled down slightly and allowed to vibrate or oscillate vertically between P and Q. And which statement is correct based on the highest or most KE and the highest GPE. So in this question, the highest GPE, of course, the most GPE will of course be at the highest position, so which will be in P. So where would it have the highest KE? The highest KE will be the point where it has the highest speed. And in this case, mass M moves the fastest at the center of the vibration, and therefore the answer here will be B. Now at points P and Q, this is the point where the mass will have zero speed. There is no KE at points P and Q. It will be stationary. So you can reference this to like a swing that you sit on. So when you sit on the swing, when you're at the maximum or highest position, the speed is zero. And you move fastest when you are in the middle of the swing, and that's where your speed is the highest. In question 11, you are asked to find which student develops the most power when they climb up a set of stairs. So power is given by work done over time, which is force times distance over time. And in this question, it will be weight times distance divided by time. So the student with the highest power will have the highest value of weight divided by time, because distance is the same. So if you use weight divided by time, then for student A, it is 30, then the student B is 32.5, C is 28, and student D is 30. So in this question, student B will develop the highest power. Question 12 is about waves, and during wave motion, what is transferred along the rope? And the answer is just energy. Energy is transferred in a wave. Question 13 is to find the speed of a wave given a wave pattern. So here we have wavefronts. Each of these lines are a wavefront, and here we have 6 wavefronts, and the distance between each wavefront is 1 wavelength. So over here we have 1, 2, 3, 4, 5 wavelengths. So the wavelength of this wave will just be 20 cm divided by 5, and that will be 4.0 cm. And using the wave equation V equals to F lambda, so 4 Hertz, 4 cm, giving us 16 cm per second. Question 14. Test your understanding of the correct ray diagram for a reflection. So over here, the answer will be C, because that is where when you trace back these light rays, and when you trace it backwards, you will find the image of O. Question 15. Test your understanding of reflection. So here we have a student separated by a wall with 4 pins, and which pins will the student see in the mirror. So the first thing you should do is to draw the images of pin 1, 2, 3 and 4. So here we have the 4 images, and from these 4 images you will draw a light ray to X. And from this light ray you will draw from the object to the point of incidence in the mirror. And you will realize that of these 4 red lines, light ray 1 and 2 are blocked by the walls, and so these light rays will not reach X. So in this case, the student at point X will see pins 3 and 4, and so that will be the answer. Question 16. Test your understanding of refractive index and which angles of incidence and angles of refraction. So from light ray 1, you can find that the angle of incidence is 60 degrees and the angle of refraction is 36. While from light ray 2, it is 30 degrees for the angle of incidence and angle R for the angle of refraction. So N, the refractive index, is given by sine I, always in air, over sine R, always in glass. And that will give you sine 60 over sine 36 for light ray number 1 to sine 30 over sine R for light ray number 2. And solving this, you will find R will be 20 degrees. Question 17. Test your understanding of refractive index. And over here, the angle of incidence is given by this angle I, and the angle of refraction is given by this angle R. So to produce the largest angle X, you want a small angle R, which means you want a high refractive index. A high refractive index will result in light bending more towards the normal and will produce a smaller R and therefore a larger X. And therefore, in this question, the refractive index will be given by 1.8, and doing some calculation using n equals to c over v, you will get the speed of light as 1.7 times 10 power 8 meters per second. Question 18. Test your understanding of the images formed by a converging lens. So in this question, to get the same size, image that is the same size as the object, you need to place the object exactly at 2f. So when the object is exactly at 2f, it will produce an image exactly at 2f that is of the same size. Question 19. Again, test your understanding of images formed in a converging lens. And so here, from the original thumbprint, you can observe that a larger thumbprint was observed. And so here, this is the application of a magnifying glass. And so this is the ray diagram for a magnifying glass, and the answer will be D. Question 20. Test your understanding on the applications that uses infrared radiation. So of these 6, the fire alarm, thermometers, and the remote controllers are some of the applications that uses infrared radiation. Optic fibers uses visible light. Sterilization and sunbathe will use ultraviolet. So over here, 3 of these applications uses infrared radiation.